Okay, so welcome to section 3.5, polynomial long division. Polynomial long division. Okay, so let's recall normal division. So recall. We usually have some number d. Actually, let me move this down a bit. Some number d divided into, let's call it a capital number d. And there'll be something on top, which I'm going to put as a q. And then with our work, it comes down to something I'm going to call r, where we have d is the divisor. It's little d is the divisor, capital D is the dividend, little q is the quotient, and little r is the remainder. Oops, what's going on? Remainder. Now in this case, little r means remainder. And don't worry, we can differentiate it from radius, but we'll get to that in a moment. So for example, e.g., let's say I had a divisor of, I don't know, let's do 3 into a dividend of 22. I claim that this goes in 7 times, and the interim gives me 7 times 3 is 21, which I will then subtract from the line above, leaving me with a remainder of 1. So in this case, we had that 3 was a divisor, because that's what I'm dividing by. What you're dividing by. Dividing by. We had that 22 is the dividend. What's being divided into? So what's being divided into? We have 7, which is the quotient, and that's the whole number part. So whole number part. And last but not least, we had 1, which is the remainder, and the remainder is the fractional part. So fractional part. So let's consider what I mean by these whole number and fractional parts. So if I had, so that is i.e. id est, that is id est, i.e. If I had 22 divided by 3, so 3 is what I'm dividing by, 22 is what I'm dividing into, that's going to be equal to a whole of 7 plus a remainder of 1 over my divisor, which is 3. So that is 3 goes into 22 7 whole times with 1 left over. Okay, so hopefully that makes sense. So polynomial long division is best shown by example. So polynomial long division. So if the dividend, let's call it p of x because it's a polynomial that I want to divide, is greater than or equal to the degree of d of x, the divisor, then we can perform polynomial long division in order to find the quotient q of x and the remainder r of x. Okay, so this is where remainder r of x is going to differ from radius r of x. Sorry, radius is just r, whereas in polynomial long division, r of x is actually a function. So the only way to show polynomial long division is to show it. So for example, I'm going to show this by way of illustration, and hopefully the more we do, the more it'll make sense. So perform the following division problems. So number one, pardon me, let's have p of x be equal to 3x to the fifth minus 2x to the fourth plus 7x cubed minus x squared plus 3x minus 5. And let's have the divisor, d of x, be equal to x cubed plus, no, that's too difficult. Let's make it easier. Let's do x squared plus x plus 1. Okay, so what I want is I want to have my p of x. So 3x to the fifth minus 2x to the fourth plus 7x to the third minus 1x squared plus 3x minus 5. And I'd like to divide it by x squared plus x plus 1. That's the goal here. So we're going to use what's termed polynomial long division. So much like I did the long division problem up here, we'll set it up the same way. So we have x squared plus x plus 1, which we are going to divide into our dividend. Why does it always do this? As follows. So this is going to be a long dividend. It is 3x to the fifth minus 2x to the fourth plus 7x cubed minus 1x squared plus 3x minus 5. Okay. Okay, so the first step of polynomial long division is I look at x squared and I ask myself, what do I need to multiply x squared by to get 3x to the fifth? And that's going to be 3x cubed. Do you agree? Actually, let me code that in a different color. Let's do this in orange, shall we? So I believe that 3x cubed is what I need to multiply x squared by in order to get 3x to the fifth. So once we have that, we're going to distribute 3x cubed to every single term of the divisor. And we're going to put that answer underneath. So 3x cubed times x squared is indeed 3x to the fifth. Plus 3x cubed times x is going to be a positive 3x to the fourth. Plus 3x cubed times 1 is just 3x cubed. Notice that the powers in each term are under the powers they coincide with. Okay, so let me erase some of these lines. Hopefully you see what I did there. I just distributed that. So now, remember, what did we do? We subtracted 21, right? And that's what we're going to do here. We're going to subtract the line we just got. Okay, so 3x to the fifth minus x to the fifth is indeed 0, which is what we want. So now distributing the negative, negative 2x to the fourth, and then negative 3x to the fourth will be negative 5x to the fourth, because both of them are negative because I'm subtracting. Now the next term is 7x cubed minus 3x cubed. So that's going to be 7 minus 3 is 4x cubed. And then we just bring down the remaining terms. So these just come down like they would in a normal long division problem. So now we're going to have minus x squared plus 3x minus 5. And we start again. So we ask ourselves, what do I need to multiply x squared by in order to get negative 5x to the fourth? Well, definitely a negative 5. And x squared times x squared is x to the fourth. So there we are, and we begin again. So we're going to distribute negative 5x squared to each term in the divisor. So what does that give us? Negative 5x squared times x squared is negative 5x to the fourth, as it always should be the same as the first term. Then negative 5x squared times x is going to be negative 5x cubed. Then negative 5 times 1 is going to be negative 5x squared times 1. And that is what we are going to subtract from the line above. Okay, so let's see what we get. Negative 5 minus 5x, negative, my goodness, I can't speak. Okay, negative 5x to the fourth minus a negative or plus 5x to the fourth goes away, which it should. So that's good. So let's go ahead and indicate that these sum to 0. Now, 4x cubed and 2 negatives make plus 5x cubed is going to be 9x cubed. Negative x squared and 2 negatives makes this plus 5x squared. Will give us a plus 4x squared. And then I'm going to go ahead and I'm going to bring down the 3x and the negative 5. So this will be plus 3x and minus 5. And then we start again. I look at the first term here. What do I need to multiply x squared by in order to get 9x cubed? And I claim that that'll be 9x. So once again, I'm going to take that 9x and distribute it to every single term of the divisor. Okay, so what do we get? 9x times x squared is 9x cubed, as it should be. Then 9x times x will be 9x squared. Then 9x times 1 will be 9x. Okay, so notice once again, the power on each term is aligned, meaning 3, 2, etc. They're all the same. Okay, so we do what we do with these polynomial functions in that we subtract. Oops, oh no, what just happened? Momentito, there we go. Okay, so we're going to subtract this. So 9x cubed minus 9x cubed goes away, that's good. 4x squared minus 9x squared will be negative 5x squared. And then 3x minus 9 will be negative 6x. And then we are just going to drop down the negative 5. So minus 5. And we start again. We say, okay, what do I need to multiply x squared by in order to get negative 5x squared? And I claim that's negative 5. So now I'm going to take that negative 5 and distribute it to every single term of the divisor. Okay, so negative 5 times x squared is negative 5x squared, which is what we want. And then negative 5 times x will be negative 5x. And then negative 5 times 1 will be negative 5. So this is what I'm going to subtract from the line above. Now the 5x squareds sum to 0 because two negatives make a positive. But now I have negative 6x plus 5x will be negative x. Oops. Oh boy, why does this always happen? Okay, will be negative x. And then negative 5 plus 5 will go away. Okay, so what do we have here? Okay, what this is saying is that our quotient, the whole number part, so the quotient, is going to be 3x cubed minus 5x squared plus 9x minus 5, and our remainder is going to be negative x. Okay, so hopefully that makes sense. Let's do another one. So number 2, let's make our lives easier this time. Let's say the polynomial I wish to divide is 3x squared minus x plus 2. And let's say the divisor is x plus 1, something like this. Simple. Okay, so I have my p of x. So I have 3x squared minus x plus 2. And I want to divide that by my divisor. Let's call the divisor orange this time, not that it matters. X plus 1. So the degree of the divisor is less, and that's all I need. So let's go ahead and set up a division problem. So I have x plus 1 that I'm dividing into the polynomial. I might need to move this down a bit, but let's see. 3x squared minus x plus 2. Maybe I can move that down a bit. Let's see. Yeah, that works. Okay, so let's start. I need to multiply x by something in order to get 3x squared, and I claim that that'll be 3x. Once I have that, I'm going to go ahead and distribute 3x to each term of the divisor. And that gives me 3x squared plus 3x, which I then subtract from the line above. The 3x squareds go away, And I'm left with minus x minus 3x is minus 4x. Then I can drop down the 2. Actually, let me make this. So plus 2. And start again. What do I need to multiply x by in order to get negative 4x? And I claim that that'll be negative 4. So distributing negative 4 to each term of the divisor gives us negative 4x minus 4, which I'm then am going to subtract from the line above. Okay, notice that the negative 4x and minus a negative plus, which becomes plus 4x, goes away. And I have 2 plus 4, giving us a remainder, oops, always doing this, a remainder of 6. Okay, so let's see what we have here. We have that the quotient q of x is 3x minus 4. And we have that the remainder, r of x, is 6. So what does that mean? That means that 3x squared minus x plus 2 divided by x plus 1 is going to be the whole number part, 3x minus 4, plus the fractional part, 6, divided by x plus 1, because that's a fraction. Or that's a divisor, rather. But note, what I could do to this is I could take this and I could multiply through by x plus 1 if I didn't want denominators, which I don't. So distributing to each term, so let me just copy and paste this. So copy, paste. So if I distribute on the left-hand side the x plus 1, remember it's all over 1, so there's always going to be a whole number denominator. This will now be the quantity 3x minus 4 times x plus 1 when I distribute, plus 6, oh wait, wrong color, plus 6 divided by the quantity x plus 1, which I'm multiplying by x plus 1. So let me keep the colors the same. Okay, so I've distributed x plus 1 to each term. Notice that I can reduce the x plus 1 here and reduce the x plus 1 here. So we get that 3x squared minus x plus 2 can be written as, I'm going to keep this as 3x minus 4 times x plus 1 plus 6. So what is that in terms of what we have here? Well, the blue guy was our p of x, so that which the polynomial we're dividing. The purple guy is our quotient. The yellow guy now is our divisor, so I'll call this d of x, plus the green guy is our remainder, r of x. So we could also write division like so, if you care. This was just an aside. So let's do one more of these for good measure. So let's say we had p of x is equal to 2x to the 4th plus 3x squared minus 1. And our d of x was 3x minus 5. Okay, so we have to note p of x is actually 2x to the fourth plus 0x to the third plus 3x squared plus 0x minus 1. So we need to account for every power of x from highest to lowest. And our divisor, d of x, is just d of x, right? It's still just 3x minus 5. Okay, so we want to find 2x to the fourth plus 0x cubed plus 3x squared plus 0x minus 1, and we want to divide it by 3x minus 5 using polynomial long division. Okay, so this is actually my trick to see if anyone's listening. If this is on a test or a quiz, one of these three, I don't require you to do any of this part. And if you do, I know you weren't listening to this video. Okay, moving on. Okay, so we're dividing into our quotient is going to be 2x to the fourth plus 0x cubed plus 3x squared plus 0x minus 1. Okay, so what do we get? I ask myself, what do I need to multiply 3x by in order to get 2x to the fourth? Well, how do I get rid of the 3? I'd have to divide by 3. And how do I introduce a 2? Well, I'd have to multiply by 2. So I claim it's 2 over 3. These are terrible numbers, aren't they? You know what? Let me make my life easier. I don't want you to have to deal with fractions while we're still learning this. Let's make our lives just a tad bit easier. No fractions in the division problem for the time being. I'll leave that for later when we have easier means by which to do this. Okay, so where was I? Okay, so now I can get rid of these fractions. Let's get rid of these fractions. So now it looks like I just need to multiply by 2x to the third. Thank goodness. So much better. Okay, now distributing that to each term of the divisor, we get 2x to the fourth minus 10x to the third. Hence why I needed the extra 0, because I needed that placeholder. Because when I do my subtraction, that placeholder needs to be there. So the first term sums to 0, but then 0 minus a negative or plus 10 will be 10x cubed. And what I'm going to do with the rest of these is I'm going to drop them down. So I'm going to drop down the 3x squared, 0x, and the minus 1. So we get plus 3x squared plus 0x minus 1. And we start again. What do I need to multiply x by in order to get 10x cubed? And I claim that that will be 10x squared. Now when I distribute that to each term in the divisor, what do we get? Well, we will get 10x cubed minus 50x squared. That's without fractions. Imagine if I'd left the fractions. Maybe I shouldn't try and make these things up on the fly. They're too ugly, aren't they? So 10 minus 10 goes away, but 3x squared plus 50x squared will be 50x squared. Then once again, we're going to drop down the 0x and the negative 1. So plus 0x minus 1. And start again. So what do I need to multiply 50x squared by, x by in order to get 50x squared? And I claim that that will be 50 just x to the first power. So let's distribute that 50x to the x minus 5. So I claim we will get 50x squared minus 5 times 5 is 25, so that's 250x, which then we're going to subtract from the line above. So the 50s go away, and that 0 plus 250 will be 250x. Let's drop down the negative 1. Minus 1, and we start again. What do I need to multiply x by in order to get 250x? And I claim that that's 250. So distributing 250 to the x minus 5, we will get 250x minus 25 times 5 is 125, so 1250, which we're then going to subtract from the line above. The 250x's go away, and I'm left with a remainder of 1250 minus 1 is 12. Oops. Well, can't teach an old dog new tricks. It's going to be 1249. Okay, so my quotient, q of x, is going to be 2x cubed plus 10x squared plus 50x plus 250. And my remainder is going to be, oh, okay, that looks like I'm drunk. I'm just very tired, not drunk. Okay. Okay, my remainder, r of x, is going to be 1249. Okay, so we see this is cumbersome, right? If only there was a better way. So synthetic division. Synthetic division. So let p of x be a polynomial function. That's supposed to say function. And d of x be a linear divisor. Then, and only then, may we use synthetic division. And once again, much like polynomial long division, synthetic division is best shown as opposed to writing rules. It's just easier. So example, evaluate the following. Evaluate the following. Oh my goodness, these ants. The following. Using synthetic division. And I'm going to do, did I use any linear? Yeah, I have two problems up here that have linear divisors, so I'm going to do them again. Yeah, okay. So, number one. Actually, let me make one up for number 1. So let's have p of x be, let's do 5x to the 7th minus 2x to the 6th plus 9x to the 5th minus x to the 4th plus 2x cubed minus 3x squared plus 5x minus 1. Let's have d of x be equal to x plus 1. Okay, so with synthetic division, we have p of x, actually, let me just rewrite it, 5x to the 7 minus 2x to the 6th plus 9x to the 5th minus x to the 4th plus 2x cubed minus 3x squared plus 5x minus 1, which we are dividing by. Now let's do orange. X plus 1. So before we go any farther, note that x equals to negative 1 is the root. X equals to negative 1 is the root. And that's important because that's what's going to go on the outside, so negative 1. And now we're going to have an upside down division symbol as opposed to the right side up division symbol. For synthetic division, it's the opposite. So now I look at the coefficients of x in descending order. So meaning going down on the power of x. And those appear to be 5, negative 2, 9, negative 1, 2, negative 3, 5, and negative 1, and I still needed more. Okay, so we put the coefficients, meaning the numbers attached to all the powers of x, from highest power of x to lowest power of x. And the process of polynomial long division is as follows. You drop down the lead coefficient here. So let's call this, 5. And then we multiply what we drop down by this negative 1. So 5 times negative 1 is going to be negative 5. Then what we're going to do is we're going to take this column and add it together. So negative 2 plus negative 5 is negative 7. Then I'm going to start again. I'm going to take this negative 7 and multiply it by negative 1, giving me a positive 7. Then I'm going to take and add the entries in this column together. 9 and 7 is going to be 16. Then I start again. I'm going to take the 16 and multiply by negative 1. So I get negative 16. I'm going to add these two together. So I end up with negative 17. And I start again. I'm going to take this negative 17 and multiply by negative 1. So what I get is a positive 17. Put that in the next column and then add these two together. 2 plus 17 is 19. And then I start again. So 19 times negative 1 is going to be negative 19. I'm going to add this column together. Negative 19 plus negative 3 is negative 22. If I did my math right. So I'm going to go ahead and then start again. Negative 22 times negative 1 is going to be positive 22. I'm going to add this column together. 5 and 22 is 27. Then I'm going to start again. Okay, so 27 times negative 1 is negative 27. I'm going to add these two together. And what I'm going to get then is negative 28. Then I stop. And usually what we do is we put a little box around this last one, like so. So what have I just done here? The quotient, oops, wrong color, it should be orange. So the quotient, Q of X, quotient, has these coefficients here. So it's going to be 5 times x to some power. And what power is that? Well, it's always 1 degree less than the original. So the original was 7, so this is going to be 6. So 5x to the 6th, then negative 7x to the 5th, then plus 16x to the 4th, then minus 17x cubed, then plus 19x squared. These are terrible. I can't even write. Then minus 22x to the first power and plus 27. Whereas my remainder is going to be negative 28. Okay, so let's see if that's true. Let's do the other ones we've already done. So let's try this one again. Copy. Paste. Okay, so let's have this be P of X. Okay, so this is number 2. Guess I should move that over one. Okay. So we have 3x squared minus x plus 2, and we want to divide that by x plus 1. Well, I claim that that means the root is x equals to negative 1 is the root. Guess I like negative 1. So I'm going to put a negative 1 on the outside. We're going to put a big upside down division symbol. Then I'm going to look at the coefficients of x from highest to lowest. So it looks like it's 3, negative 1, and positive 2. So step 1 is to always just drop down the 3. Come on, nope, okay, it's not going to autocorrect. I got a new Apple Pen, a lot of good that did. So we drop down the 3, and we start, du liebe Scheiße. Okay, we're going to start by multiplying. So 3 times negative 1 is going to be negative 3. Put that in the next column and add this column together. So negative 1 plus negative 3 is negative 4, and then we start again. So negative 4 times negative 1 is going to be positive 4. Going to add this column together, and I claim the remainder should be 6. Okay, well, let's see if that matches what we got before. So the degree of the dividend was 2, right? The highest power was 2. So I claim that the quotient will be 3x to the first power minus 4, and the remainder is going to be 6. Was that what we got above for this? 3x minus 4 and 6? Is that what we got? 3x minus 4 and 6? Yes, we did. So that's much easier, isn't it? Okay, so number 3. So let's do this one. As long as our divisor is linear, we can use synthetic division. So we cannot use synthetic division if our divisor is not linear. Okay, so once again, we've got this 2x to the 4th plus 0x to the cubed plus 3x squared plus 0x to the first minus 1, which we are dividing by the divisor, x minus 5. So what is the root in this case? The root is going to be x equals to 5. So that's what I'm going to put on the outside of my synthetic division, the 5, the root. Now, let's look at the coefficients in descending order on our dividend, which is going to be 2, 0, 3, 0, -1. You have to account for every missing power of x, counting down from whatever the highest power is. So we drop down the 2, and we start the process. 2 times 5 is 10, so that's what I'm going to put in the next column, and then I'll add these two together. So 10 plus 0 is 10, and then we'll start again. What is 10 times 5? Well, 10 times 5 is 50. So I'm going to add these together. So what do I get? 53, right? Why does this not seem right? 4, 3, 2, 1, 0. It should be right. Okay, we'll see. We'll see what happens. Maybe I did something crazy. I hope not. Okay, so what is 53 times 5? Well, 50 times 5 is 250, and 3 times 5 is 15, so that's going to be 265. So I might have made a mistake above. I'll have to check. So this is 265. I think I did make a mistake above because synthetic division is so easy. I don't think I made a mistake here. So we'll have to go back and check that. So what's 265 times 5? Well, 200 times 5 is 1,000. 6 times 5 is 30, so that's 300, so 1,300. 5 times 5 is 25, so 1,325, which I'm going to add to this. So I'm just subtracting 1, so I should have a remainder of 1,324, which I know I didn't above. So I might have made a mistake above. Let me go check that. And sorry for doing that, because I believe this should be the real answer. So I claim the quotient, in this case, is going to be 2 times x to 1 power less than 4. So that's going to be 3. Plus 10x to the second, plus 53x to the first, plus 265, and the remainder will be 1,324. Okay, so let's see what I did wrong up above and why polynomial long division is so terrible. Ah, there it is. What is 3 plus 50? It's 53, not 50. So that changes everything. Okay, so what I'm going to do, I'm going to cut this part and cut, I need to cut this part. Let's see, maybe I do. Okay, let's see what I should have gotten. 10 minus 10 is 0. 3 and 50 should be 53x squared. Then plus 0x minus 1. So what do I need to multiply x by to get 53? So that's going to be 53x, which when I distribute will give me 53x squared minus, okay, 53 times 5. 5 times 5 is 250. 3 times 5, so that's 265 times x. And that's what I'm going to subtract from the line above. And that'll give me what I'm looking for. Because now the 53's reduce, and I am left with 265x minus 1. When I bring that one down, let's go ahead and do that. Okay, and now 265 times x will give me that last term, so plus 265, leaving me with 265 times x minus, well, 200 times 5 is 1,000. 6 times 5 is 30, so that's 300, so 1,300. And 5 times 5 is 25, 1,325. So yes, indeed, looks like we will be left with a remainder of positive 1,325 minus 1, so 1,324. Okay, so I need to adjust this. My quotient is now 53x plus 265, and my remainder is now 1,324. So I had it wrong doing it the hard way, which doesn't surprise me. The hard way is terrible. When, if at all possible, always do it the easy way, synthetic division. So let me try again. Let's, because I messed up. Let me give you guys a problem. So number 4. Actually, let's make this a new example. So example. Prove that polynomial long division is the same as synthetic division for the following. Okay, so number 1. So I'm just going to go ahead and look at the book's examples. What do they want? Synthetic. Oh, okay. I guess I'm not allowed to go in. Let's see. So let's do 33. X to the 4th minus 8x cubed. So we have p of x is x to the 4th. Wow, I can't even remember it. X to the 4th minus 8x cubed. What's the next one for 33? Plus 24x squared minus 32x, so plus 24x squared minus 32x. Plus 16 divided by x minus 2. Okay, plus 16. And we want to divide this by x minus 2. So we're going to do this 2 ways. So I'm first going to take my polynomial and do long division. So we want x to the 4th minus 8x cubed plus 24x squared minus 32x plus 16, and we're going to divide that by x minus 2, which is linear. As long as my divisor is linear, I can use synthetic division. So let's go ahead. Have x minus 2, and we're dividing that into, using polynomial long division. This is going to be into all of that big long polynomial there. Come on, autocorrect. Nope, it's not going to do it. Okay, fine. Okay. It's really everything. Okay. Let's go ahead, just copy and paste this. Okay, so we know how to start this. Polynomial long division. What do I multiply x by in order to get x to the 4th? And I claim that that's x cubed. So now what I'm going to do is I'm going to multiply x cubed by each term of the divisor, which gives me, actually let me erase this, that's going to give me x to the 4th minus 2x cubed, which I am then going to subtract from the line above. Okay, so what do we get? X to the 4th minus x to the 4th goes away. Negative 8 plus 2 is negative 6x cubed. What am I going to do with the rest of this stuff? I'm going to bring every single term down. So I'm going to get plus 24x squared minus 32x plus 16. Okay, so we start again. We say, what do I need to multiply x by in order to get negative 6 x cubed, and I claim that that's negative 6x squared. Then I multiply negative 6x squared by the whole divisor, giving us negative 6x cubed plus, because there's two negatives, 12x squared, which we're then going to subtract from the line above. Okay, so the 6x cubes go away. 24 minus 12 is 12x squared. Then I'm going to go ahead and bring down the remaining terms. Okay, so what do we have? We have minus 32x plus 16. And we start again. Erase this. Okay, so what do we want? What do we multiply x by in order to get 12x squared? And I claim that's plus 12x. Gesundheit, kitty. Then we're going to distribute the 12x to x minus 2. So we're going to get 12x squared minus 24x, which I am then going to subtract from the line above. The 12x squareds go away. Negative 32 plus 24 is going to be negative 8. Hopefully. At this point, I don't know if I can do subtraction. So let's drop down the 16 and start again. What do I need to multiply x by in order to get negative 8x? And I claim that that's going to be negative 8. So let's distribute that negative 8 to the divisor. So I claim we get negative 8x plus 16. Oh, interesting. I guess they made that work. Okay. That's what happens when the book does it and your instructor doesn't. Because do you agree the remainder is 0? Let me make that solid lines. The remainder is 0. So now we have a quotient. Q of x is x cubed. Notice that x cubed is 1 degree less than x to the 4th. So x cubed minus 6x squared plus 12x minus 8. So the remainder, r of x, is 0. That means that my divisor, x minus 2, goes into the dividend or the polynomial evenly. It's a whole number. So let's try this again with polynomial long division. So what is my root? Let's look at the root. Let's go back to here. So do you agree that x equals to 2 is the root? So what I'm going to do is I'm going to have 2 on the outside, my upside down division symbol. Come on. Apple pencil. Okay. So what are the coefficients in descending order? Looks like it's 1, x to the 4th. Then negative 8. Then positive 24. Then negative 32. Then positive 16. Okay, so first step for synthetic division is to drop down the lead coefficient, which is 1. Then we multiply 1 by 2. We get 2, and we add the next column. So adding the next column, 2 minus 8 is negative 6. Then we start again. We multiply negative 6 times 2, and we get negative 12. Adding this column together, what do we get? 24 minus 12 is 12. Okay, start again. 12 times 2 is going to be 24. We're going to add these two together. So 24 minus 32 is going to be negative 8. Then we start again. Negative 8 times 2 is going to be negative 16. we add this last column, and what I get in my last column should be my remainder. And we get 0. Thank goodness. And let's make sure that the coefficients here are the same coefficients for q of x above. 1, -6, +12, and -8. Check mark, they are. And check mark for the 0 remainder. So it does work. Okay, so let's see if they've got another one that maybe doesn't go in perfectly. Let's do one with a coefficient like 36. So 4x to the 4th minus 2x cubed. So p of x is equal to 4x to the 4th minus 3x cubed. Did I say 3 or p? I don't even know at this point. I'm so delirious. Oh, it's minus 2x cubed minus 4x plus 2. Okay, so minus 2x cubed minus 4x plus 2. And there's a sneaky something going on here. And the divisor is going to be 2x minus 1. So there is a coefficient, which is good, because I wanted to show you this. Okay, so there's something interesting about this polynomial in that it's missing terms, right? So we have 4x to the 4th minus 2x to the 3rd, but there is no x squared. So I need to add 0x squareds to this. Then I can continue with the minus 4x and the plus 2. Now every power of x has been accounted for. My divisor is going to be 2x minus 1. Okay, so now let's go ahead and do polynomial long division. So 2x minus 1 into what is this? 4x to the 4th minus 2x cubed plus 0x squared minus 4x plus 2. Okay, so what do we have? 4x to the 4th. What do I need to multiply 2x by to get? Well, 2 times 2 is 4, and I would need another x cubed to make that work. So there we are. I claim the first term of our quotient is 2x cubed, which I'll now multiply by the divisor. So 2 times 2 is 4, x to the 4th. Then minus 2x cubed. Okay, oh, this is interesting. Wonder what's going to happen here. So everything goes away, and then I need to just drop the remainder. If there's a 0, I can ignore it now. I didn't know I could ignore it before. So now we're just going to get negative 4x plus 2. What do I need to multiply 2x by in order to get negative 4x? And I claim that that's negative 2. So multiplying negative 2 times the divisor, I claim we get negative 4x plus 2. Oh, they did it again. Why did they do this? Why don't they give us a remainder? Okay, so it appears as though our remainder is 0. Okay, well, we can check this with synthetic division. What's important? Why, Steve Jobs? Why? I just don't get it. Okay, so do you agree our quotient in this case, q of x, is 2x cubed minus 2, and our remainder, once again, was 0. So let's see if we get the same thing when we do synthetic division. But, so if I have a divisor of 2x minus 1, then what we want to do is set this to 0 to find the root. So I can actually get rid of the parentheses. So that means that 2x is equal to 1, which means that x, let me just go ahead and keep it in the same color. So x equals to 1/2 is the root. 1/2. Okay, see what happens. So let's put a 1/2 on the outside of my upside down division symbol. Let's do my coefficients in descending order, which were 4, -2, 0, -4, and 2. Let's drop down the lead coefficient, 4. And now let's divide by, okay, oh, I see what's going on. Maybe. Ah, yes, I do. Okay. I'm like, why is it not working? And it is, and I'll show you why. Okay, so we drop down the 4. We're going to divide by 2. So 4 divided by 2, which is multiplication by 1/2, is going to be 2. We're now going to add these together, and note we get 0. Then we're going to start again. 0 times anything is 0. I don't really need to worry about that one. Add these together, we get 0 again. 0 times anything is 0. Finally, we have something non-zero. So -4 plus 0 is going to be -4. And now we're going to start again. -4 divided by 2 is going to be -2. Add these together, and I get a remainder of 0. Okay. So the issue was that I needed to divide each of these by 1/2. So my quotient, right now, you would think the quotient is 4x to the, well, 1 power less will be cubed, then -4, because I have 0. But what I need to do is I need to take that 1/2 and multiply by 1/2 or divide by 2. So therefore my quotient will indeed be 2x cubed minus 2. So that's one way of attacking it. Another way will be as follows. So that was 1, 2, let's do 3, and let me see if I can find one that isn't going to work out nicely. Don't like it when they work out nicely. It upsets me. Okay. Okay, so specify the quotient and remainder. Okay, so these ones actually do have a remainder. Let's do number 6. That looks good. Okay. Or even, yeah, 6 is good. So we have 4x squared minus 10x plus 6. So p of x is equal to 4x squared minus 10x plus 6. And we're going to divide that by 4x plus 2. 4x plus 2, and this is what I wanted. Okay. So we have 4x squared minus 10x plus 6. And we're dividing this by 4x plus 2. 4x plus 2. But before we move on, let's note something. So 4x plus 2 is really 4 times the quantity x plus 1/2. Okay? So if we know that, that is going to help us later on when we use synthetic division. So I claim that x equals to -1/2 is the root. But for now, let's do our regular polynomial long division. So we have 4x plus 2 into 4x squared minus 10x plus 6. Okay, so what do I need to multiply 4x by in order to get 4x squared? And I claim that's just x. There's already a 4. So now let's multiply x by the whole divisor, and we will get 4x squared plus 2x. I'm then going to subtract this from the line above. The 4x squareds go away. Negative 10x minus 2 will be negative 12x. And what I'm going to do is I'm going to drop down the plus 6. And we start again. What do I need to multiply 4x by in order to get negative 12x? And I claim that that will be negative 3. So multiplying the whole divisor by negative 3, we get negative 12x minus 6, which I'm then going to subtract from the line above. Thank goodness it doesn't give me a 0 remainder. Ugh, thank God. Okay, I wanted something other than 0, so 6 plus 6 is 12. Whew, our remainder is 12, yay. Okay, that's good, that's good. Okay, so my quotient, q of x, is x minus 3, and my remainder, r of x, is 12. And let's see if we get the same thing using synthetic division. So I claim that the root was negative 1/2, as I found up here. So let's do negative 1/2 on the outside of our upside down division symbol. And the coefficients in descending order are 4, negative 10, and positive 6. So we drop down the 4. Right away we can see something's wrong, but it's actually not. So 4 times negative 1/2 will be 4 divided by 2. So negative, oops, wrong color. Negative 2. I then add this column together. 2 negatives, so it's negative 12. I start again multiplying negative 12, or dividing negative 12 by negative 2, and I claim that I get a positive 6. Add these two together, and lo and behold, my remainder is okay. Okay, but what about my quotient? Well, my quotient, according to this, will be 4x to the first minus 12. But I actually need to divide it by what? Well, what else was here? What did I factor out here? I factored out a 4, so I'm really dividing by 4 and by this. So the synthetic division only took care of this second factor. I still have the 4, though. So let's go ahead and divide by 4. When I do that, I'm left with x minus 3. So it's up to you which way you think is easier. Oh, and also the remainder was correct. Which way you think is easier. I personally really like synthetic division, though it does take a while to get used to. Okay, that's it. I'll see you guys in the next section.